Hi students, welcome to our channel Physics Concepts by Ali sir. In today's session, we are going to discuss about one of the chapter of 10th standard heat one short video. This is for the purpose of Polycet. The Polycet one set, then this is the video for one short video we are going to discuss, and that is about heat. Then here is first of all, this session will be taken into the three parts. The first part is the total explanation of the chapter. The second part is then important the concepts will be written on the board. The third session is this is about the numericals. Then what are the important numericals will come from this one will be discussed. Now let us see first of all what is meant by heat and what are the forms of how the heat will transfer. Those all things we will discuss first. And so the first one, when we are seeing about heat, so the first, now let us take the definition. What is the definition of a heat? As heat is a form of energy that is transit in nature. Transit in nature in sense that transfers from one body to the another body. What body to what body it will transfer? Generally that will transfer from a hot body to the cold body. So heat will transfer from hot body to the cold body. And if the heat is transferring from a hot body to the cold body, then what will happen? And heat will, once here is the temperature, once any one body is, we discussed about the heat will transfer from hot body to the cold body. Okay, if heat is losing by any one body, that body will become cool. Okay, when from any one body heat is releasing out, that body will become cool. What is an example we can take? When we are catching ice cubes, then we are feeling cool. What is the reason? When we comparing with ice cubes, our body temperature is more. So we will feel cool as the heat is transferring from our body to the ice cubes. Okay, got it? So the next change is, then if anyone heat is transferring, energy is transferring from the hot body to the cold body. And so then what are the changes will be in the cold body? If any one body is receiving temperature, that body will become so hot. So how can we say that one? And when we supposed to take an example, when we are standing in front of a fire, we are feeling very hot, very warm. What is the reason? The reason is then our body is receiving lot of hotness. Because of that, our body will feel very hot. Did you get it? And in this way, just we can take that heat transfers from the hot body to the cold body. How much time the heat will be transferred? Now the heat will be transferred till both the bodies acquires the same temperature. Then what do we call that one? That is we are calling as thermal equilibrium. What is meant by thermal equilibrium? It's one of the very important topic. Thermal equilibrium in sense, thermo is, so here is, then the next one is we can take as thermal equilibrium. So what is meant by this thermal equilibrium? Thermo means heat, equilibrium means state of equalness. If the heat is transferring from a high energy body, hot body we used to call it as, to low energy body, that is a low cold body we used to call it as. If that is, for example, this is the hot body, this is a cold body, the heat will transfer from a hot body to the cold body. Till what time? Till extent that temperature will be transferred or energy will be transferred, till both acquires the same temperature. The temperature, if any one system reaches such temperature state, we used to call it as a thermal equilibrium. Now let us see one question you can expect from the thermal equilibrium. What are the properties of this thermal equilibrium? If any one system is in thermal equilibrium, then what will happen? Then the first very important thing is, then all the components of the system will have the same temperature. What is the reason? If this is any one body is there, and for example when you supposed to think about that, and here is then till here the energy is there, and till here only and energy is there. This is a hot body, assume that this is a cold body. And so then if we are, because of this block, the water level is not traveling like this, even energy also. Energy is not traveling towards this side. But once when I remove this one, then what will happen? Two things will be takes place. The first one is the heat will be decreases, the energy level will be decreases this side, and energy level will be increases this side. Then what is happening? And in both the cases, the heat is transferring from the hot body to the cold body. Till what time the transfer of heat will be takes place? Till the both bodies will acquire same temperature, and that is we are calling as thermal equilibrium. Thermal equilibrium in sense, if two system, in the two components, not only two components, how many components also there in the system, those all components will have same temperature. Means for example, when we suppose to take, then if any one component is, one system is there, in that system three components are there. It's a very important one, and three components are there. Now let us assume that A component, B component and C component. These are the three components of any one system. In that system, then A is having, now let us take A is having some 6 degrees Celsius. Then how much heat, this one statement was given, that is this system is in thermal equilibrium. This entire system is in the thermal equilibrium. A temperature is given 6 degrees. How much heat will be transferred to the B body? If A body is having 6 degrees Celsius, B body will have, this is very important one, B body will have how much temperature? Then there will be the same temperature that will be. Then how much heat will be transferred? No heat will be transferred. Okay, two important concepts here. The first component, the first important thing is, if any one system is in thermal equilibrium, all the components will have the same temperature. Why? If there is a temperature difference is there, then the heat will transfer till both will acquire the same temperature. So then only it acquires the thermal equilibrium, no? So then what is meant by that? Then once if all the components of the system reaching to any one particular temperature, then we can say that is thermal equilibrium. So if any one system is in thermal equilibrium, what can we say that one? That entire system components consist of same temperature. So if A is 6 degrees Celsius, this system is in thermal equilibrium, B2 have 6 degrees, even C2 have 60 degrees. That is the first point of the thermal equilibrium. What is the second point? If the system is in thermal equilibrium, how much heat will transfer from A to B? How much heat will be transferred from A to B? Both are having equal energy levels. This side is having this much energy, even B also having same energy. Then where is the place to transfer the heat? So no heat will be transferred. Most important bit this is, if any one system is in thermal equilibrium, no heat will be transferred. Okay, that is we are calling as the thermal equilibrium. Now let's come to the next point, that is then more detail about heat. And so we learned about thermal equilibrium. Heat generally represents with the letter of Q, and the units of heat, the two systems we will take, and the first system is in the Cbse system, and in the next system is in the Mks system. In the Cbse system, heat measures in the calorie. In the Mks system, heat measures in the joule. Also we can say this is, what is the relation between these two? 1 calorie is equal to, most important, this is 4.186 joules. You have to keep this in mind. So this is about the heat. How the heat can be measured? Heat can be measured with the help of a calorimeter. Okay, that is about heat. Now let's go the next one, that is temperature. And what is meant by temperature? As then very simple definition is there for temperature, that is degree of hotness or coldness of a body. What does that mean? Then when we are supposed to catch ice cubes, we will feel it's too cold. Whereas when we are sitting in front of the fire, we are feeling this is too hot. What is the reason? That is the expression of the temperature. Means the degree of hotness or coldness of your body. If any one system is having some energy, how much intensity of that energy? Means how much the energy is. Either the energy is more or the energy is small. That tells you about the temperature. Temperature in sense, that is nothing but it is a measure of the intensity. How much more or how much less, that is we are calling as a temperature. Ultimately what we can say for temperature? Temperature is nothing but it is a degree of hotness or coldness of a body. And this temperature generally we supposed to take, we will express that in different scales. What are those scales? The first scale what we can take it is, that is in the degree Celsius. The Celsius is name of the scientist, on his name we used to call it as a degree Celsius. And few values you keep in mind, that is first one is a melting point of ice, that is equal to 0 degree Celsius. And again boiling point of water, that is 100 degree Celsius we have to take. And this is one measure, and the second measure is the most important one, and that is we are calling as a Kelvin temperature. Also we can call it as a absolute temperature. Absolute temperature. And this degree Celsius generally we express with a small t, and Kelvin temperature generally we express with a capital T. What is meant by this Kelvin temperature? Kelvin temperature I have two definitions, and the first definition is the temperature where all the molecules are at the state of rest. The temperature is called as a Kelvin temperature. And also we can say that one more definition is, if the temperature is expressed in the Kelvin, we can say that is a Kelvin temperature. And what is the value of this Kelvin temperature? Sometimes it is coming in the exam also as graph, and generally the graph will be here is, and we will take the graph like this. As this side is we will take the temperature, and so this value is minus 273.15 degrees Celsius we can take, minus 15 degree Celsius also we can take. This is we are calling as a Kelvin temperature. Okay, and this Kelvin temperature generally represents with a capital T. Okay, and degree Celsius is a small t. Then what is the relation between these two temperatures? And here is there is a conversion is there. Based on this one, you can expect one question also. What is the conversion? Conversion if then small t is given, means degree Celsius is given. This is degree Celsius to Kelvin. These all sums we will do, don't worry about it. If the temperature is given in the degree Celsius, for example 10 degrees Celsius, then how can we convert that one? By means of this formula. Capital T is equal to 10 plus 273. We will get 283 Kelvin. That is degree Celsius to Kelvin. What about Kelvin to degree Celsius? Now let us see. And small t is equal to capital T minus 273. What is this one? Kelvin to degree Celsius. In this way, just we can take down the different type of temperatures. How can we measure the temperature? Temperature generally can be measured with the help of a thermometer. Okay, that's all about temperature. And see the next one is then the heat we discussed about, and heat is what is meant by heat? Heat is a form of energy that is a transit in a nature. Okay, then what are the factors that a heat is depending? It's important. Heat majorly depending upon mainly two factors, and what are the factors is the first, the factors heat affects on mass of the substance. Okay, what is the relation? If more mass is there and more temperature, more heat has to be supplied. More mass is there, more heat has to be supplied to get heated. If you want to heat any one substance, then depending upon its mass, supplying energy will be depends. Means less mass is there, less temperature. More mass is there, more temperature. That can be expressed as Q is directly proportional to M. The next one is change in temperature. So change in temperature. Change in temperature and change in temperature, and change is expressed with delta T, delta, and temperature is T. And see what is meant by that? And heat is all the time depending upon the change in temperature. Means when we are supplying more temperature, that will be more heated. Less temperature, less heated. These two combining, we will get one equation, this most popular equation, and we will just based on this one sums will come. That is Q is equal to Ms delta T. And this is the most popular formula to find out the amount of heat given. And what is this Q is? Q is called as heat, M is mass of the substance, and S is specific heat, and delta T is change in temperature. And from this one, then what we can take? S is equal to what we can take? Q by M into delta T. Q by M into delta T. This S is called as a specific heat. Now let's discuss about the specific heat. What is meant by specific heat? Whenever the word comes specific heat, immediately one word should strikes you. Then that is a reluctance. Reluctance in sense which opposes the changes. What is meant by opposes the changes? One simple example now let us take. And when we are supposed to take oil in one beaker, water in another beaker, now let us start heating that, and water generally will takes lot of time to get heated, but oil will get quickly heated. Means water is having some certain temperature. It would like to continue the temperature for long period of time. It won't change immediately. It takes lot of time to change its temperature. Whereas the same, then if you supposed to take ice water when we are placing in the open atmosphere, it takes a lot of time to get heated. Means it won't continue, it won't change its current coolness for long period of time. That coolness will continue for long period of time, in sense it is opposing the changes from its current state. Whatever the state is there, either hotness or coolness, that state it would like to continue for long period of time. This is we are calling as the reluctance. Reluctance is nothing but specific heat. What is meant by specific heat? The substances which are having high specific heat, then what they will do? They will continue their current status for long period of time, whatever may be that, if it is hotness or coldness. That is we are calling as a specific heat. And the specific heat is generally, the formula for specific heat is S is equal to Q by M into delta T. S is specific heat, Q is heat, M is mass, delta T is a change in temperature. What is the definition we can take for specific heat? Many times asked the temperature, the definition for specific heat. The amount of heat required to change the temperature by 1 degree Celsius of 1 gram mass of a substance. 1 gram mass substance is there. To change its temperature by 1 degree Celsius, how much heat is needed? That heat is called as a specific heat. Okay, now ultimately what is meant by the specific heat? It is nothing but heat. Now let us take the units. What are the units? 2 units we can take in the Cbse system. Cbse system, heat is measured in the calorie by gram degree Celsius. Also we can say calorie gram inverse degree Celsius inverse. This is in the Cbse system. In the MK system, or also we can say SI system, the heat is measured in the joules. Joule by mass is in the kilograms and delta T is in the Kelvin. So also joule per kg Kelvin. Also we can say joule kg inverse Kelvin inverse. Is there any relation between these two? Yes. And the relation between these two, what we can take it is 1 calorie per gram degree Celsius is equal to 4.186 into 10 cube joule per kilogram Kelvin. Also simply we can say 4186 joule per kg Kelvin. This value you have to keep in mind, and the reason is then in the nature then which is having highest specific heat? Then water is having the highest specific heat. How much is that value? That is in Cbse system 1 calorie per gram degree Celsius. In the MK system, that is 4186 joule per kilogram Kelvin. So this value you have to keep in mind. The question will be asked, many times this question was asked. Which substance is having the highest specific heat? Which substance is having the highest specific heat? Water is having the highest specific heat with how much value in the in the Cbse system 1, in the MK system 4186. Next one is, what are the applications of specific heat? This is most important one. Now let us take 3 applications of the specific heat, and the first application is then because of this high specific heat of water, then Earth atmosphere is getting stabilized. So the specific heat is called, the water is having, because of the water's high specific heat, that hotness will continue for long period of time, which makes the Earth atmosphere at equator, at polar region equal. Okay, no? That is we are calling as that is why the ocean is called as storehouses, energy storehouses of Earth. This bit is important, which is called as these all bits. Just I will give you notes on that. Don't worry about it. And ocean water is called then heat storehouses of the planet Earth. Okay, that is the first application. The second application is watermelon. Watermelon, when you are keeping the watermelon in the fridge, after long period of time also, if we suppose to see that watermelon inside, when you are keeping out of the fridge, the watermelon consisting the coolness for long period of time. What is the reason? The watermelon, the water is there. What is the large quantity of water is present in the watermelon? That is water, and so water specific heat is very high. So then what will happen? Then the water will becomes because of high specific heat of water, that coolness will continue for long period of time. Because of that reason, when we are keeping the watermelon in the long period of time also in the fridge, that becomes very cool. And the next one is then samosa. When we supposed to take the samosa, when you are keeping the samosa in when we going to the just anyone bakery, and the samosa, then he will keep that in the oven, and afterwards once when he is applying us, then we will wait for some time. But after some time when we are about to eat, then the samosa will appear as very hot. What is the reason? Because the ingredient which is present inside of the samosa is having high specific heat. Okay, no? These all we are calling as the specific heat, the applications. And the next one is then principle of methods of mixture. It's important one. What is meant by this principle of methods of mixture? Principle of methods of mixture. Principle of methods of mixture, also we can call it as a principle of calorimetry. Okay, then what is meant by that? It is simply we can call it as a heat lost. This is the heat lost by hot bodies. Heat lost by hot bodies is equal to heat gained by the cold bodies. Heat gained by cold bodies means what? When we supposed to take 2 bodies are there, when we are taking the 2 bodies with different temperatures. So when we are keeping this high temperature, this low temperature, when we are keeping in the contact, then what will happen? This body, hot body will lose the temperature, cold body will gain the temperature. How much energy it is losing? That will be equal to the gaining energy. That is we are calling as a principle of methods of mixture. Heat lost by hot body is equal to heat gained by the cold body. Okay, now did you understand that? That is the principle of methods of mixture. It's important. And afterwards, then what is the resultant temperature formula? Resultant temperature means when we are taking two different temperatures. When we are taking two different temperature substances and when we are combining those two, how much will be the resultant temperature? For example, let's take one beaker which is consisting of 50 degrees Celsius, another beaker that is 20 degrees Celsius. Now let us pour these two different temperatures substances in any one big beaker. How much will be the temperature of the resultant one? Not 70. And there is a formula for that one. What is the formula? That we can take it as M1T1 plus M2T2 by M1 plus M2. What do we call this one? This is the formula of resultant temperature. Okay, that's about resultant temperature. Now here the next one is the most, based on this one we can expect one sum. So the matter exists in how many states? 3 states. What are those 3 states? Solid state and liquid state, and also we can say that is a gaseous state. Okay, and here is once the question was asked. Here is A, B, C, D is given. What do we call A, B, C, D? Not alphabets. Okay, and A in sense then the process of converting a solid state to the liquid state. What do we call that? Is melting. A is called as a melting. A is a melting. And what do we call B? The process of converting then liquid to gas. That is we are calling as then if it is taking place by external energy, that's we are calling as boiling. And if it takes place on its own, we used to call it as evaporation. And next one is C. Then this is the reverse process, no? Then gas to liquid. What do we call that? Is condensation. What do we call? Condensation. And then liquid to solid. What do we call that one? That is we are calling as freezing. So these are the 4 states, and these all things we will discuss once. Okay, and here is the C. Then right from left to right means if solid to liquid, liquid to gas, heat energy will be absorbed, isn't it? And how a solid can becomes, for example, now let us take ice cubes. What is the state of ice cubes? What is the state of ice cubes? Solid state. And how the solid states can be converted into liquid state? By supplying heat. And so solid to liquid in sense heat is absorbing. Whenever in any one situation heat is absorbing, we used to call it as such reactions are called as endothermic reaction. Heat absorbing in sense endothermic reaction. Okay, that is about solid to liquid, that is melting and not that much important. And liquid to gas, this is the most important. And liquid to gas, then we used to call it as evaporation. What is meant by evaporation? And this is the most important one. One bit you can expect on this one. What is meant by evaporation? The process of converting liquid state into gaseous state at any temperature. At any temperature. At any temperature, then liquid can be converted into the gaseous state. At any temperature. So it doesn't require any external factor. On its own, it can be takes place. That is we are calling as evaporation. And how this evaporation will be takes place? Very simple reason we can take. And for example, how this evaporation will be takes place is. And now let's take any one bowl and which is having then this type of large surface area. Assume that it is made up of molecules, and here is one molecule is there. Now let us take A and this is a molecule. Now let's call it as A, and this is a B molecule, and this is a C molecule. 3 molecules are there, and these 3 molecules when we supposed to take actually this according to the kinetic theory of gases, and according to kinetic theory of gases tells you that every matter is consisting of molecules. Those molecules are randomly in the motion. They used to randomly move all the sides. And here also the molecules are randomly in the motion. So because of that random in motion, C is trying to, this one is moving all the sides. And so then what will happen? Whenever any one molecule or any one matter is in the motion, that will have energy. That energy is called as a kinetic energy. And so then this object is having energy. So it is trying to go out. It cannot go because B is the hurdle is there. So it is stopping this one. So in the meanwhile what will happen? This supplies energy to B. And so B will get, already B is having energy because B is also in the vibration. So B will get energy. And afterwards then what will happen? This B will supply energy to A. So ultimately what will happen? A will get large quantity of energy, and so this will fly off into the atmosphere. As A is atmosphere just escaping into the atmosphere, then already we learned that. What we learned, whenever if any one system is losing energy, that will become cool, isn't it? Whenever any one system is losing energy, then what will happen? That system will become so cool. What do we call that? Is nothing but evaporation. So ultimately what we can say, one very important point we can take here, that is evaporation is evaporation. This is a cooling process. Evaporation is a cooling process. And at what temperature it is taking place? It doesn't require any temperature. At any temperature it can be takes place. And so the second important point is it can takes place at any temperature. At any temperature it can be takes place. And the most important one is, then here is there any factors are that influences evaporation? Is evaporation will takes place at any condition like the same or different? Different. This is just depending upon some factors. What are the factors? The first very important factor is, the factors that influences evaporation is larger surface area. Larger surface area. Larger surface area means if surface area is more enough, then the evaporation will be takes place more. For example, one question will be asked like this: if you have given a small cup and a saucer, then in which part the evaporation will be takes place faster? Saucer. What is the reason? Saucer is having larger surface area. So larger surface area, larger evaporation will takes place. And the second one is, and if wind speed is there, then what will happen? The molecules will fastly, they will move. So more wind, more evaporation. And next one is, and more temperature. If temperature is more, in such case also evaporation will be takes place faster. And the fourth one, it is just opposite. More humidity is there. More humidity. More humidity, what is meant by humidity? Amount of water vapor present in the atmosphere. More humidity in sense less evaporation. This is the reverse. Remaining all are both the same only, but this is the only part that will be separately. More humidity, less evaporation. So these all are the factors about evaporation. Okay, got it? What is meant by evaporation? Those all things. Now let us take the next part is. And here is now let us see what is the remaining part of these conditions. And here is now, okay, right? Then we have seen that evaporation is taking place from liquid to gas. And sometimes even if let us think in the reverse, the gases to liquid. What do we call this one? That is we are calling as a condensation. What is meant by condensation? Condensation in sense the process of converting a gaseous state into the liquid state. Gaseous state to the liquid state is called as a evaporation. And see, now here is one very important thing is, the condensation is a warming process. Why it is a warming process? And see here, the solid is becoming ice cubes are there. Ice cubes, how the ice cubes can becomes into water? By supplying energy. Means once these ice cubes are supplying, just receiving energy, absorbing energy, and so they are becoming liquid. So liquid is consisting some energy, no, because it is receiving energy, right? And afterwards these liquids still they are getting energy, that time they will convert into the gases. So ultimately what we can say, among solid, liquid, gas, which is having high energy? Gas is having high energy. And if the gas, when we are reverse, when we are making the gas into liquid, that absorbed energy will be released outside, right? Then absorbed energy will release out, no? So then what do we call that is condensation? Is the process called as condensation? Condensation is a warming process. Condensation is a warming process. Why it is a warming process? Why? Because then this is energy is releasing outside. This type of reactions are called as exothermic reaction. In any chemical reaction, if heat is energy is released out, such reactions are called as exothermic reactions. So then condensation is a warming process, very important, warming process, not a heating process, not boiling process, only warming process. Okay, now condensation is a warming process. And the most important one is, next one is, condensation is a reverse process of, what is the reverse process? This is a reverse process of what? Evaporation, isn't it? Because then liquid to gas, what do we call that is evaporation. Gas to liquid is called as a condensation. What is the practical examples we can see in our practical life, the condensation? And for example, when we are taking any one cool drink bottle, when we are keeping in the fridge, after some time, when we are keeping out the cool drink bottle outside in the atmosphere, we can see the water droplets. What is the reason for these water droplets? The reason for this water droplets is it's nothing but condensation. How it is happening? See, this is very cool drink bottle. It is consisting, the outer layer is a lot of coolness is there. Once all side the gas molecules, water vapor molecules are traveling, right? According to the kinetic theory of matter, every matter is consisting of molecules. Those molecules are randomly in the motion. And so then what will happen? These molecules will come and strike like this. As the water molecules are coming and striking the cool surface, then immediately what will happen? They will become so cool and they will become into water. So that is we are calling as condensation. Did you get it? What is meant by condensation? And what else also just we can take? And here is two words we can take, dew and fog. These are the examples for the condensation. What are those? The first one is dew and the second one is fog. What these two? These two also the one of the applications of condensation only. When dew will forms, when fog will forms, if the temperature in the winter season, the temperature is going down, means the temperature is reducing, then what will happen? That water vapor present in the atmosphere becomes cool. As the water vapor is becoming cool, then what will happen? These will become water droplets at the window panes, at the leaves edges, and if you are keeping any vehicles outside, at the edge of the vehicles, these water droplets will be formed. That is we are calling as a dew. Then what is fog? This one also one of the consequence of application of condensation only. If the temperature is still going down, then what will happen? In the atmosphere dust particles are there. Every dust particle around it, then these water molecules will come and join. The dust particles are there, every dust particle around that, these molecules will come and join. Then what will happen in such case? Then how many dust particles are there? Millions of dust particles are there. And so how many water molecules will come? Each and every dust particle, water molecule will come and join. And so then what will happen? A thick layer will be formed. That thick layer is nothing but fog. So these two also applications of condensation only. Understood what is meant by condensation? And now let us take one more very important one, that is boiling. So what is meant by boiling and those things we will see. The most important point this is, and boiling and again evaporation, both are same. Why these are same? They both converts into the liquid state to the gaseous state. What is meant by boiling? And the process of converting liquid state to gaseous state by external energy. External energy means this boiling cannot take place on its own. When we are supplying heat, then the molecules will get energy. The molecules again what will happen? They will escape into the atmosphere. This process call it as then boiling. And here is this boiling is there, and how this boiling will be takes place? Now let us see. And for example, when we supposed to take, then these are again water molecules. In this water molecules, and when you are supplying energy, then what will happen? Here is A molecule is there. And now let us take, and here is A molecule is there, and this is a B molecule is there, and this is C molecule. Once when you are supplying energy, then what will happen? This A molecule will get energy, and so it will come starts traveling like this. Even B molecule also will get energy, it will travel. C molecule also will get travel. Means what is that? Any molecule can escape into the atmosphere. Not only A, not only B, not only C. So this is we are calling as a boiling is a bulk process. Evaporation is a surface phenomena. Evaporation takes place only at surface, but boiling takes place at any surface, because this is a bulk process. And this is a boiling. Once when you are supplying the heat, no, then what will happen? And so here is, then at some extent, now you start take water and you supply heat. Then what will happen? Just with the help of thermometer, and you just see the water gets start boiling. That time the thermometer shows 100 degrees Celsius. Still you supply energy, still it shows 100 degrees Celsius only. The water vapor, what will happen? From this water, the water vapor is coming out. Find the temperature of that one also. That too also 100 degrees Celsius only. But here, we are going on supplying energy. What is that energy? Where that energy has gone? That can be measured by means of a latent heat. What do we call that? Is a latent heat. What is meant by latent heat? Latent is a Greek word which means hidden. Latent heat in sense, then hidden heat. What is meant by the definition for latent heat? L is equal to Q by M. Then what is meant by this latent heat? The amount of energy required to convert 1 unit mass of a substance from one state to another state at a constant temperature. At a constant temperature. Before we learnt about the specific heat, that is for change in the temperature. Specific heat is for a change in temperature. This one latent heat, this one too for change in temperature only. But what is the difference? That is for change in temperature, but this is a change in the temperature, change in the state of mass. state of a substance at a constant temperature. One example I will say. And for example, when we are going on heating, then what is happening? What is the very beginning of the state? That is a liquid state, water. What the state is that? That is a liquid state. And what is this state? This is a water vapor. And water vapor in sense, what is the state? That is a gaseous state. And see here, what is changing? Water, and it is converting into water to water vapor. Water to water vapor. And so water temperature, how much is that? 100 degrees Celsius. Water vapor temperature also, how much is that? 100 degrees Celsius only. Means the amount of heat required to convert matter from one state into another state. States are changing. At what condition? Temperature is constant. This is we are calling as the latent heat. So this latent heat is how much is that? And the formula for latent heat is L is equal to Q by M. What is the formula then? What is the units we can take? In the Cbse system, calorie per gram. In the Mk system, what we can take that one? Joule by kg. That is, we can take it as a joule by kg. Okay, and this latent heat, then two values we have to take. Latent heat of water vapor, I will give these all values, don't worry. Latent heat of water vapor, that is equal to 540 calorie per gram. Calorie per gram. And so then the question will be asked you like this: if boiling water is falling on hand, it won't hurt, but whereas hand is exposed to the steam, that will causes lot of damage. What is the reason? Because it is consisting of an extra energy inside of that. How much energy is that? That is 540. What do we call that energy? Latent heat. The latent heat we are calling as. And afterwards, even ice cubes. Ice cubes temperature, how much is that? 0 degrees Celsius. Ice cubes, once when they are melting into water, how much temperature? That would be 0 degrees Celsius only. But we supplied energy, otherwise the energy will be absorbed by the atmosphere. What about that energy? That energy will used to change only the state but not changing the temperature. Temperature will be remains the same, but what will be changed? The state will be changed. What do we call that one? That we are calling as a latent heat only. How much is that latent heat? Latent heat of the fission is equal to, how much we can take? That is 80 calorie per gram. How much is that? That is 80 calorie per gram. So the question will be asked, when ice melts, its temperature dash remains constant. Temperature won't be changed. What will be changed? State will be changed. Okay, that is we are calling as the latent heat. Okay, and last topic is that is generally, now if you suppose to take, and I will write here, and here is then what is this one is this is any one metal substance, and this is, let us take 10 meters. When we are supplying heat, then what will happen? This will slightly, the length will be changed. Length will be, now let us take 10.5 meters, it is changing. Means what is happening? By supplying heat, matter shows expansion. Okay, by supplying heat, matter shows expansion. Where at the same time, when you are cooling, then what will happen? This 10 will becomes 9.5. Means that will contract. That will contract. But water, so simply what we can say, matter can show expansion by heating and cooling by contracting by cooling. Contracting means shrinking. Shrinking by cooling, but water shows a peculiar behavior. This most important bit, this is water shows the expansion by cooling. Water shows expansion by cooling. Okay, got it? And that's all about the entire session and this explanation part. And now you can take just the what are the important concepts. Only these concepts will come, and those concepts will write now. See Nana, these all are the important bits what you can take for. Maximum you can get the bits only from this one. And see here, these all bits just you take down. Totally 20 bits I have written. And take a screenshot of this one. Later you can write the remaining part also. And still matter of 10 more bits are there. Those bits also just you can 100%, 99.99% that you can expect from the heat lesson. Only these bits you can expect. Just go through that once, these all bits, then you will get it. Take a screenshot of these all, then we will continue the further also. Take a screenshot, Nana. See here, Nana, the light also there. And so here, these all bits I have taken. The remaining part of the bits, these 34 bits, enough to you, more than enough. It takes you very little bit time to revise these all. You just go through these all. It may take matter of 1 hour just revise these all bits. 99.9% from this lesson, these bits only will come. Okay, right? I hope that this session is very helpful for you. In the next video, just we will discuss about what are the numericals are present. What are the numericals will come from this chapter, we will discuss. Those numericals only, very simply, just we will discuss in a simplest way. Everything you will understand very easily. I hope that this session is very helpful for you, and please support me, Nana. Wish you all the best.